All right, so today we're looking at 3.8. We're going to talk about what is a function. But first we need to talk about what is a relation. So a relation is going to be any set of ordered pairs and an ordered pair is basically some number x, some number y. Okay? So you're going for a function, you're going to look at that relation and see if it only has one output. So you're going to take a relation which has only one output. Okay? So I'm going to show you what I mean by that. All right, so your inputs are going to be your x's. That's your inputs. Or they often, or most often, use the word domain. And your y's are your outputs. That's basically your range. So you've got your domain and your range. Sometimes you see it in a T-chart. Sometimes you see it in this oval thing as like part of a Venn diagram. Or sometimes you see it just listed as a set of points. So that's how we're going to do it for example number 1. We're just going to write a bunch of sets of ordered pairs. So the first ordered pair is 1, 2. That means we plugged in a 1. It goes through the little function, whatever you do to it, and 2 is the answer. Then we plug in a 2. Goes through the function, whatever happens to it, spits out a 3. Then we plug in a 4, goes through the function, do whatever you need to do it, spits out a 5. Then we plug in a 1, goes through the function, spits out a 3. Then we plug in a 2, and it spits out a 6. Anybody see a problem? So right here, I put in a 1, what did I get? Right here, I put in a 1, what did I get? A 3. So that means this is not a function because right here, I plugged in a 1 and got a 2, and then right here, I plugged in a 1 and got a 3. Something's wrong with the function. Okay, same thing happened with the 2. Right here, I plugged in a 2 and got a 3. Over here, I plugged in a 2, got a 6. Okay, if I plugged in a 1 the second time, what number should I have got now? A 2. If I plugged in a 2 a second time, what should I have gotten? A 3. Okay, if you have all nice different answers, all of your domains are different, you get different numbers, you're going to have a lovely little function. But if you have this put in a 1 and get out a 2 and then a 3, then you get a plug in a 1 and get out a 3, that's going to make it not a function. Okay? Or the 2. Both of those kill it. Okay? On the assignment, you're going to be asked to do something called a mapping. Oh, sorry. Example number 2. A mapping diagram. You're going to take the points 0, 4, 1, 3, 2, 3, 3, 5, 4, 4, and 5, 4. Okay? If you're asked to do this mapping thing, it basically means you're going to, shrink that down a little bit. There we go. Now you can see it. You're going to put your inputs or your x values in the first oval, and then you're going to map them or connect them to your outputs or your y values. Okay? So all of our x values, we have 0, 1, 2, 3, 4, and 5. And our outputs, we have a 4, a 3, a 3, a 5, a 4, and a 5. So basically we have 3, 4, and 5. And the 0 maps to 4. The 1 maps to 3. The 2 maps to 3 as well. The 3 maps to 5. The 4 maps to 4. And the 5 also maps to 4. Okay? So every number that we put in, we only put it in once. Okay? So we actually say that this one is yes, it's a function, because the inputs were only used once. It's okay that the outputs were used more than once, but the inputs were each only used once. So that's what happened up here. We plugged in a 1, we got a 2. And then when we plugged in a 1 again, we got a 3. So that's what makes it not a function. But down here, it's okay that the outputs were used more than once. Okay, any questions on that part? All right, I'm going to move this up. Anybody still need to see it? We're good? All right. Another kind of problem you're going to see on the assignment is like example number 3. We're going to be given a function. We'll call it f of x. Sometimes you see it like this. Sometimes you'll see like this. Either way, this means the same thing. The function is 4x minus x squared. Okay? Basically, every time you see the x, you're going to plug in the values that they give you. All right? So if I give you a domain of 1, 2, 3, 4, and 5, it means to take those values, and every time you see x, you're going to plug it in. So we're going to do 2 things. First, we're going to find the range. And then second, we're going to graph it. Okay? So on your paper, you can make a T-chart, right? And we talked about this last week or the week before. If you're really good with doing these calculations in your head, then you can just do an X and a Y column. Okay? Or if you know how to type it in your calculator really fancy and it spits it out for you and you always get it correct, just do an X and Y column. Okay? But in the notes, I'm going to show the work column and then the Y column. On your assignment, you know where you're at. You decide, yes, I need to do the work column, or no, I'm good at this, I don't need it. Okay? So we're going to plug in 1, 2, 3, 4, and 5. And so let's plug in 1 right here and 1 right here. So we're going to have 4 times 1 minus 1 squared. 4 times 1 is 4. 1 squared is 1. 4 minus 1 is 3. So if we plugged in a 1 and we got out a 3, that means our ordered pair is 1, 3. Now we're going to plug in a 2. So we're going to have 4 times 2 minus 2 squared. 4 times 2 is 8. 2 squared is 4. 8 minus 4 is 4. So the ordered pair that goes with that one is 2, 4. Number 3, we're going to plug in a 3. So 4 times 3 minus 3 squared. 4 times 3 is 12. 3 squared is 9. 12 minus 9 is 3. So the ordered pair is 3, 3. Now let's plug in a 4. So we have 4 times 4 minus 4 squared. 4 times 4 is 16. 4 squared is 16. 16 minus 16 is 0. So the ordered pair is 4, 0. Now we're going to plug in a 5. So we have 4 times 5 minus 5 squared. 4 times 5 is 20. 5 squared is 25. 20 minus 25 is negative 5. So the ordered pair we got there is 5, negative 5. Okay? So all these guys in this column, if they ask, are your domain. All these guys that we just spit out after we did the work on them are called the range. If they say they want the domain in the range, you list both. If they say they want the range, just list the range. Okay? So let's graph this. So here's our x-axis. Here's our y-axis. First point is at 1, 3. So go 1 to the right, up 1, 2, 3, put a point. Next point is at 2, 4. 2 to the right, up 1, 2, 3, 4, put a point. 3, 3. So over 3, up 3, put a point. 4, 0. 1, 2, 3, 4. Don't go up any. And then 5, down 1, 2, 3, 4, 5. What's this a graph of? Is it a line?
It's a parabola.
It's a parabola, right? Opening down, going this way. Sometimes they're going to ask you to graph it, or they'll give you a graph, and then they'll say, is this a function? And you can do something called the vertical line test. Okay? And once you get the vertical line test, you'll be able to answer yes or no. Okay? So for the vertical line test, you take your pencil, you start with it going straight up and down, vertical, right? Okay? You're going to move it across the paper, and it can only touch 1 point at a time. So right here, how many points is it touching? Just 1. How many is it touching right here? 1. How many is it touching right here? 1. So it's only ever touching 1 time. So we say yes. You always say yes when it only touches the line 1 time. Or it's that. Is that saying it right? Yes. So 1 at a time. Versus if it touches 2 or more points, you say no. Okay? What would be an example of that? Okay? We're just going to draw a rough little sketch right here. So here's your x-axis. Here's your y-axis. Second semester, we're going to get into something, excuse me. We're going to get into graphs that are like ellipses and that kind of thing. So something like this, where it's like a stretched oval, that's called an ellipse. So if you had a point right here and a point right here, as you're doing your vertical line test and going across right here, it's going to touch 2 points at a time. Or over here, it's going to touch 2 points at a time. So this one would be no. That makes sense? All right, one more thing to talk about. And that's plugging into a function. So example number 4, where you have something called a composition of 2 functions. So example number 3, we just had 1 function, right? We had the f of x. For example number 4, we're going to have the f of x is x squared minus 1, and a g of x is 1 minus 2x. So now we've got 2 functions. And you're going to see them written 2 ways. You'll either see f on the outside and then g on the inside, or you're going to see g on the outside, f on the inside. Okay? So these, when you do these, you have to complete them in 2 steps. And the 2 steps you're going to do, you're going to work from the inside out.